Hey, AP Computer Science, this is Mr. Roberts. Today I am out of class and should be back Monday. Um, we're working on activity two, and one of the things I want to point out, even though some of you haven't submitted activity one yet, is the fact that once you open the starter code for activity two, um, there is a complete implementation of the card class that's shown. Now, obviously, a lot of these things you would probably write exactly the same way. Some of them might be a little bit different, but I do encourage you to kind of look at what you perhaps wrote for activity one and compare that with the code that they have in activity two. I think it's a lot cleaner. Nick did a great job in period four yesterday walking us through some things, but like for example, we were looking at this matches class or matches method. I like this because the fact that you can have this multiple lines, you're writing basically one statement. There's the final semicolon, but we're breaking that up over 3 lines, makes it a lot more readable. Um, and notice that we're not doing any if or else. We're just saying we want to return the truth of something or the falsity of it, and we're going to return. So this whole thing will be true or false. So we're returning whatever it is. And if the other card's suit, so we're calling the method to that, is equal to this card suit. And it is interesting, this is actually calling the method up there, even though this method matches has access to the field variables. We're not using the fields here, we're just using the method that gives us back the fields. So I think it's probably nice because the structure kind of parallels. We've got two things. We've got the card that they handed us, and we're comparing it to ourselves or to this particular card. Or for a card to compare itself to another card, it looks at its suit, and if it's equal to the other card's suit, if the rank is equal to the other card's rank, and this whole statement would be true, and it just returns that. So I think that looks clean. Another thing is the discussion in activity one about the override method. I think is worth kind of looking at and reading again. They try to make the case that when you do this, it's forcing you to override something that exists in a parent class. And if you accidentally had typed this with the lowercase s there, well, the parent class doesn't have a two-string lowercase method. So if you were to hit compile, look what the compiler says. It says here, class has to be not that. It's not telling me anything. Oh, it's off on the other screen. Yeah, off on the other screen, it's giving me the error message that you're intending to override a parent method, but the parent method doesn't have, the parent class doesn't have a method called toString. So as soon as I change this back to toString, there. Now the other thing is, speaking of parent classes here, it's not obvious if you just look at the top that this is extending anything or that it has a parent class. It just says public class card, except every class in Java extends the generic object class, so that's what's being extended. Anyway, so kind of look at your code and perhaps compare it to what the author of this lab wrote. They gave you that here. But then we're moving on to the deck class. And for the deck class, there's some things that we're implementing and there's some things that we're not implementing. So don't yesterday I worked with a student in sixth period, and we basically did something we weren't supposed to do until activity 4, but I didn't notice that it said to be implemented in activity 4. So don't get ahead of yourself, just do the things that it's asking you to do. So we are writing a class that represents a deck of cards, and if you think about things that you do with a deck, you take cards out of the deck when you're playing a game. So the deck gets smaller as cards go elsewhere, they go to other players. You definitely need to shuffle a deck. You don't want the deck to have all the cards in perfect order. And you need to know when the deck is empty, when there's no more cards in the deck. So when you look at this partial implementation of the deck class, realize that a lot of thought has gone into what a deck is and how a deck should behave. They're using the array list often, so that's here. There's a reason why the College Board has this import statement, import Java util list. And I guess I agree with it. They're using this more generic definition, but then to create it, the constructor has to, even though this is a list, if I was to come down here and say, okay, so I'm going to have two field variables. One is going to be size and one is going to be list. And size is the number of not yet dealt cards. Cards are dealt from the top, highest index, down, the next card. Okay, so I've got two of these. I've got the list and this. Well, if I come down here and I'm going to initialize my deck, right? So it's a list. Or if I'm going to initialize this collection of cards, right? This is the deck of cards. This variable cards is my reference to this object. I could come down here. I could say cards equals new, and then I'm just going to type this to show you what happens. New list of card objects, although this is not necessary. It's a call to a constructor, so I have open close parentheses and then semicolon. When I hit compile, the compiler hollers at me. It says that the list is an abstract class and it can't be instantiated. So this list just kind of lays out that all the methods that anything that's implementing it should have. And the thing that we're using that's implementing the list interface is the array list. So you can't, once you see that, and if you see the error, it's like, wait a minute, remember, list is just an abstract class. It's just a list of methods that something has to have if it's implementing this list interface. But you can't create a list. What you can create is an array list. And then compile. And that's fine. So what I've done here is I've now initialized this cards as an array list of card objects. Now, the other thing that's happened here is the constructor is, I'm being handed off three arrays: an array of strings, not an array list, but an array of strings, an array of strings called ranks, an array of strings called suits, and an array of values. Suits, it depends on the cards, but on a standard deck of playing cards that we use, there are 4 suits, right? You've got the club, the diamonds, the spades, and the hearts. So there's 4 of those. And there's 13 ranks in a standard deck of cards, and every single one of those ranks has a matching point value. So these two arrays, ranks and values, will have the same number of elements, whereas this will have a different number. And I just point this out because I think there's probably going to be perhaps a nested for loop that'll go through, and maybe for every suit it will match up a rank and a values. This seems fairly simple to implement. The deck object that we have, right, is the thing called cards. And if it's empty, if it has no cards left, it should return true here. And I think you guys can figure out how to find out how many cards this thing holds. So I'm getting far afield. Let's go back and look at the lab manual for just a little bit, because there's a good conversation here. So it says complete the implementation of the deck class by coding each of the following. Now it doesn't say everything, but it says each of the following. So we're going to complete the constructor, is empty, size, deal, and just that. Those are the ones that we're going to implement. So the constructor receives 3 arrays as parameters. The arrays contain the ranks, suits, and points value for each card in the deck. The constructor creates an array list and then creates the specific cards and adds them to the list. So we already did this. We created the array list. And then it's going to create the specific cards and add all those cards to the list. The reason why we can't hard code that is for this example right here. We can't just think about our cards, right? A standard deck of cards with 4 ranks and 13. With 4 suits and 13 different ranks. Because you could have a card that is used in a kids game, right? Where you've got the ranks A, B, and C, and you've got the suits of giraffe, lions, and then the values are 1, 2, 3. So the card ranked A has a point value of 2, the card ranked B has a point value of 1, and the card ranked C has a point value of 6. And you can see if we were going to, when we make the cards, we would need to have the card with a rank A that's a giraffe has 2 points. The card rank B that's a giraffe has 1 point, and the card rank C that's of giraffes has 6 points. So you can see that the ranks and the point values are matching up, right? This A is going with the 2. This rank is going with 1, and this rank is going with 6. And then these suits, you've got the giraffes and you've got the lions. So the constructor would create the following cards and would add each of them to the cards array list. Well, this is not difficult, right? To add something to an array list, you look it up. How do you add something to an array list? This thing definitely has a method. You can type cards, hit the dot, and then control spacebar and figure out what it is. But in order to add something to it, you need to give it an object that it's capable of holding. So create a card, and this represents a card that's created, and then add it to the deck. The parameter size would then be set to the size of the cards, which in this example is 6. So I guess as you're adding these cards, or after you're adding all the cards to the deck, you probably should come along and go ahead and say, get the size of the array when you're finished, and then set the field variable size equal to the size of this thing's, how many cards it's actually holding. Finally, the constructor would shuffle the deck by calling the shuffle method. Note that you will not be implementing the shuffle method until later. Is empty should return true when the size of the deck is 0, false otherwise. Size, this method returns the number of cards in the deck that are left to be dealt. So I think probably we should just be calling the field variable size, or we just should be returning the field variable size, and then make sure that every single time we change the number of cards in here, we update this size variable. So it's pretty simple. It'd be like size is equal to cards dot. What is the method that tells me how many cards are in here? Nice. So deal. The method deal a card. This method deals a card by removing a card from the deck and returning it, if there are any cards in the deck left to be dealt. It returns null if the deck is empty. There are several ways of accomplishing this task. Here are 2 possible algorithms. Well, actually, before I get back to this, I want to come back to this constructor and just say, I hope that you're thinking about a nested for loop. And on the outer loop, maybe you've got suits, and on the inner loop, you've just got like an index I that's going from 1 to the size, and then for for I, you're getting this and this. And if you're not sure how to make a card, because that's what you have to do, make a card, well, look at the card class and see what you need to give it to make a card. And that syntax should be, card C, I'm just picking some variable, card C equals a new card, and then you give it the three things it needs to make a card. And then once you have that card, you add it to the array list. I think that's probably more than enough to get you started. I don't want to overdo this. So yeah, that's enough. Talk to you guys on Monday.